you're going to drop any questions into the chat box. So any specific ones that you want me to go over, just drop them in there, and then we'll go over them very shortly. Okay, so just kind of a brief overview of what's going to actually be on the final exam is there's going to be 24 questions. They're all going to be multiple choice, or I'm going to say multi-select. And the reason why I'm saying multi-select is because it might say like, which of the following are true, or it might say like a little drop down thing as well. So that will be an option. So from AKS 17, 18, 20, and 21, there are 8 questions. And so this is going to relate to constraints. So we did constraints in unit 6, where we had like, you had Androids and iPhones, and you had to sell a certain amount. You saw a lot of inequalities. So something that looked like X is greater than 0, or some type of equation. So that's going to be on there. There's also going to be solving radical functions. That's what AKS 2021 is going to be. And then AKS 23, 24 is what we just finished up. So it was our last unit. So that's talking about normal curve. It's talking about the empirical rule. And it's talking about like z-scores. Okay. You will be given the actual normal curve and like the percentages that are broken down, as well as the z-score formula. So you will be given all of that information. Just make sure that you look at your formula sheet up at the top. A lot of people forget that it's there. Okay. The next AKS that you'll have, well, and I will say it's kind of like a grouping, so they don't tell us exactly how many are in each question, but so this one is pretty big. It's 9 questions. So this is dealing with key features of various different types of functions. So this could be exponential, this could be logarithm, this could be radical functions, okay? And then 51, 52 is dealing with inverse functions. Okay, so switching that X and Y and then solving for your Y. Let me make sure there's no people waiting in the room. Nope. Okay. And then like x-intercepts and that kind of thing. You're gonna see like domain and range questions in here. Domain and range, and probably like in behavior and x-intercepts. So that's probably what you're gonna see the most. Yeah, that's all you're gonna have with there. Okay. And then AKS 60 is probably y'all's least favorite. And there's only 2 questions on this, but they're kind of big because this deals with rewriting using exponent rules. Okay, so the way you're going to see this is something like, you know, here's a square root of, I'm actually going to write this out, make it a little bit easier on y'all. So an example of this is going to be something like, if I had the square root of 225, x raised to the 2nd power, y raised to the 3rd power, how would you rewrite this using exponents instead? Okay, another way you might see this, if I had something like this. All right, simplify it. Okay, so you could see either one of these questions on there, and those exponent rules are real important. So we will go over those in a little bit as we're working through a couple of problems. Okay, so these are the different types of problems that you're going to see. Again, 24 questions. You have an hour and a half to take it, so you'll be fine. Don't fret about the time frame. Yeah. So again, if you have any particular questions, go ahead and drop them in the chat box. I just kind of want to refer you to a couple of things that you should have access to it. If you don't have access to it, let me know. Give me 1 second. People are joining. And let's go here. Okay, so again, if you go to your teacher's Algebra 2 page, I'm just going to show you mine. Normally under content, they're going to have this final exam review videos. So if your teacher didn't give this to you, let me know and I can drop you the link. But down at the bottom of my page for my students, all of the review guide questions are in here, and there's videos of me working through almost every single problem. I know there's a few that I didn't do, and if you want to go over those, we can. So right now, I'm just going to kind of take any questions that you want me to go over, any that you're like particularly stuck with. Again, you can feel free to just drop it in the chat box. Number 5 and 8. Yeah, 5. Okay. All right, so let's start with that. Let's go 5 and 8 really quick. Okay, so on number 5, sorry, multitasking, it's great. Okay, so on number 5, what you're gonna do is, since both of these have this 1/2, okay, what you can do is kind of ignore those 1/2s and just set them equal to each other. If my pen will write. Okay, and then you can solve for x. Okay, so what we're going to do is move our numbers to one side. Okay, so +5 plus 5. So this is going to give me 3x plus 40 equals -x. I'm going to move that 3x to the other side. That's 40 equals -4x. Divide by -4 on both sides. So x would equal -10. Okay. One thing you must do with radicals, if you have to check for extraneous. I think I spelled that wrong, but that's okay. Extraneous solutions. Okay, so what I mean by that is, if I took -10 in, and let's say it didn't equal on both sides, like it wasn't the same number on both sides, that would be an extraneous solution. Okay, so you need to know this word. Okay, if you ask your teacher tomorrow what extraneous is, they're gonna be like, I don't know. Okay, but what we gotta do with these is we always have to check it. So we're gonna plug it back in. I don't know why this pin is jumping. All right, we're gonna plug it back into the original. So we've got 3 times -10 plus 35 equals -5 minus -10. And we're going to raise both of those to the 1/2 power. Okay, so we're going to simplify that. So 3 times -10 is going to give us -30. -30 plus 35 is going to give me +5 raised to the 1/2 power. On the other side, this negative and negative is going to turn into a positive. So -5 plus 10 is going to give me +5 raised to the 1/2 power. So it works on both sides. So our answer is -10. Okay. If my thing will load. Okay, so we're going to jump to number 8 next. Whenever this thing moves. Sorry, people keep on joining and there we go. Finally. Okay, so that was number 5. We're going to jump to number 8. I'm going to go ahead and hit clear. Remember, I will be posting this at the very end. It just might take me a second to kind of buffer through it and upload it to YouTube. Okay, so on number 8, we're trying to solve for n. Well, we need to get rid of that square root because it's kind of like it's wearing a hat. We got to get rid of it. So the only way to get rid of it is to square both sides. And when we square both sides, we're going to get 16 equals n divided by 7. Okay. So now in order to get n by itself, we're going to multiply 16 times 7. So we're going to do 16 times 7. And that's going to give us n equals 112. We multiplied by 7 on both sides. So n equals 112. Okay. Again, remember, we have to check radical answers. Okay, so checking. You're going to plug in 112 back into here. So 4 equals the square root of 112 divided by 7. Okay, so 112 divided by 7 is going to give us 16. And the square root of 16 is 4. So it works on both sides. So 112 works. Oh. Okay, give me 2 seconds. I'm going to hit pause really quick on the recording. Okay, so on number 11, what's going to happen is you're going to want to plug these into Desmos. You're going to have a couple of questions that probably are going to be like, hey, which one of the following is the graph of this equation? You need to just plug this into Desmos. You will have that feature on your final, so it will be up at the top. Just make sure you click through the different types of calculators. If for some reason your calculator is messing up, let your teacher know, and they should know how to fix it, because we had that discussion the other day. So if it freezes up for some reason, just let your teacher know, they can handle it. So when you type this in, you're going to hit square root, like you can type out square root, or you can go down to where it says functions, and then you can just go ahead and hit that square root button. Okay. All right, so 2 times the square root of x plus 2. So this is what my graph's going to look like. Okay, I'm going to go over the different types of key features that you might see on this one. Okay, so let's first talk about domain. Okay, I love you guys, but y'all suck at domain. Okay, so with that being said, that's your farthest left x value to your farthest right x value. Okay, so what's my farthest left x value? Well, right here, it's 0, 2. So that's where that radical starts, and then it goes over. So what's the x value on that one? 0. Okay, so I'm going to say from 0, and how far right does it go? Positive infinity. If you're just joining us, we're doing number 11 on our review page. For our range, our lowest y value is 2. Our highest y value is infinity. So the way I think of this is domain is left to right, and range is bottom to top. And it's kind of like, what's the farthest number on those aspects? Oh, there we go. Okay, for x-intercept, well, it never crosses the x-axis, right? So there's going to be none. Okay, for y-intercept, it's going to be 0, 2. So you want to write out 0, 2. One that we always forget to do, and I'm not sure if you'll actually be asked this question or not, but just in case, in behavior. Okay, so what in behavior is, gotta get these people. Okay, so in behavior is if you stand at 0, 0, so you're right here, and you look to the right and you look to the left, what is happening to your function? So I'm going to say as x is approaching positive infinity, so as we're looking to the right, what's happening to our y values? Well, this graph is going up, right? So y is approaching positive infinity. As x is approaching 0 from the right, and we saw this on one of our delta maths. I'm not sure if they're going to ask you this question, but you could see it. So as we're going from the right and we're looking at the left, right, looking towards the left, what's happening to our y values? Where are they going? Well, they're getting closer and closer to 2. Okay, so y is approaching 2. Again, I don't know if they'll ask you an in behavior question, but they could. Okay. I do want to go over one thing on this, and I want to go to one of the log questions because you might see asymptotes. So we're going to go down to, I think it's question 27. Yeah. Okay, so we're looking at 27. We're going to graph this guy, and then we're going to identify all the key features because you're probably going to be asked about logs at some point. Okay, so go into 27. We're going to take this and we're going to put it into Desmos. Okay, log of base 2 of x minus 1 plus 3. Okay, so go into Desmos. So when you go into Desmos, if for some reason, again, you have any issues with your calculator, let your teacher know. But you hit this little keyboard, you go to functions, and you're going to scroll down to where it says log of base A. Okay, so you're going to type exactly what you see, plus 3. Okay. Now, the domain for this one is going to be, well, what's my farthest left x value? Well, there's like something weird going on right here. So it's going to be from 1. And how far right does it go? Positive infinity. Notice how I use parentheses on both of these. Okay. For range, what's my farthest down y value? Well, it keeps going down here, right? So that's going to be negative infinity. To how far does it stop? It keeps going on forever. So that's positive infinity. Now, my x-intercept on this one would be where it crosses this x-axis. And one of the great features of Desmos is literally you can like do a little point right here. So that's going to be 1.125. 1.125, comma 0. And there's no y-intercept. Okay, so here's the new thing. With logs, you have a vertical asymptote. Okay, so you're going to have a vertical asymptote with logs. Okay, well, that's fine. I'll send Adam, I'll send you the links for all of that in just a second. So, okay, so with the vertical asymptote, it's where it approaches but never touches. Okay, and they're going to try to trip you up with this one because they're going to have answer choices that look like this. You're going to have y equals 1, x equals 1, y equals -1, x equals -1. So they're going to have these as your 4 choices for a vertical asymptote. Now we see it's happening right here, and that's at +1. So we can go ahead and eliminate these 2 options. But which one do we pick? Well, it's going to be x equals 1 because it's creating a vertical line at x equals 1. Okay. So that vertical asymptote is x equals 1. All right. In behavior, kind of the same deal as last time, but again, I'm just going to go over it just in case you see it. So as x is approaching positive infinity, so as we're moving to the right, what's happening to our y values? They're going up, right? So that's going to be y goes to positive infinity. As x approaches 1 from the right-hand side, what is y doing? Well, y is going to negative infinity. Okay. All right. So again, I think you're probably going to see something about vertical asymptotes. You're definitely going to have to recognize one of the graphs from the logs. Okay. So definitely know how to graph them and how to recognize it. If you're unsure, like if the picture on the graph is a little difficult to see, make sure that you zoom out or zoom in on the pictures, or zoom out or zoom in on the Desmos, okay? Don't let those be the ones that you get wrong. Y'all can do it, okay? If you joined us a little late, also my bad, people that are in my class, I apologize. One thing that we talked about earlier that I just kind of want to mention to y'all is here's kind of the breakdown for the final exam. So again, there's 24 questions, multiple choice, and then there's a few that are multi-select. These are the different AKS. So you'll have 17, 18, 20, and 21. So that's solving radical functions, doing constraints. 23 and 24, there's 5 questions. You're going to be asked about normal curve, empirical rule, z-scores, and yes, you'll have the formula for z-score as well as the normal curve and the percentages. AKS 34, 38, 47, 51, and 52. Those are going to be key features, exponential, logs, radicals, and then inverse functions on that. And that's a little bit of what we just went over with domain and range and in behavior and x-intercepts. I will say the one thing I didn't include on your final exam review were in context domain and range. Okay, that's one thing I didn't include because it's kind of hit or miss. Just think about it. If you put it in a real world setting, could you have negative numbers? No. So if you're talking about a real world scenario, not a function, a real world scenario, you wouldn't have negative things. Okay, so just be mindful of that as you're reading through those word problems. Okay, and then AKS 60, you'll have 2 questions, and I'll be rewriting using exponent rules. Yes, I can. Yep. And someone asked for AKS 60, so I'm going to go through those really quick. And again, this is kind of like what I think it might be on the test, because again, we don't get to see this exam, but I've predicted pretty well so far. Let's do. I'm just going to give y'all an example problem. So this is not on your review guide. I'm just kind of giving you one. So one that you might see would be something like a raised to the 2nd power, b raised to the 3rd, c raised to 0, a raised to the -1, b raised to the 2nd, c to the 6th power. And we're going to take all of that and do something crazy because, you know, just to add chaos. Okay, so let's say that we had this crazy scenario. First of all, shame on the people who actually wrote this problem because it's a lot. But let's go ahead and break it down. Okay, so just a reminder of your exponent rules. If you have anything raised to the 0th power, it's going to equal 1. Okay, so if you see this c to the 0th power, that's automatically going to be 1. You can kind of like ignore it. Okay, another thing is negative exponents flip the fraction. Okay, so if you ever see that negative exponent, so like this guy right here, boom, gonna flip the whole thing because it's around this entire parentheses. Okay, if we have a power raised to a power, then you're just gonna multiply. Okay, so what I mean by that is we have all these numbers on the inside and they're all raised to that -2 power. So you're gonna multiply 2 times 2, 3 times 2, etc. Okay, and then we'll talk about the other ones in just a second. So first thing we want to do, whenever you see that negative, go ahead and flip. So we've got this -2 right here. So I'm going to go and flip this entire thing. So I get a to the -1st, b to the 2nd, c to the 6th over a to the 2nd, b to the 3rd, c to the 0. And I'm raising all of that junk now to a +2 because we already flipped them. Okay, so all I've done, flip the fraction. The next thing I'm going to do is I'm going to multiply all this stuff by this exponent of 2. Okay, so -1 times 2 is -2. I'm going to write this in a different color to make it a little easier. a to the negative 2. This is going to be b to the 4th, c to the 12th, over a to the 4th, b to the 6th. And this c to the 0, I'm just going to ignore it because it turns into a 1. Because remember, anything raised to the 0 power is going to equal 1. Okay, so now what we're going to do is we're going to use quotient rule. Quotient rule. Okay, and so with the quotient rule, what happens is if you have the same base, so they're the same letter, you're going to subtract the exponents across. Okay, so see this negative 2? Well, since these a's are the same, you got negative 2 minus 4. So that's going to give you negative 6. So this would be written out as a to the negative 6 power. You've got this b to the 4th and b to the 6th. So 4 minus 6 is going to give us negative 2. And then we've got this c to the 12th power but chilling by itself. Now, most of our answers are not going to be written with a negative exponent. So we're going to write these all with positive exponents. So this is going to turn into c to the 12th power over a to the 6th, b to the 2nd. Okay, so all I did here was I flipped and put that a and b down on the bottom because they had that negative exponent. Okay. Again, I don't think you'll have something as extravagant as this, but you could possibly have one. I'm going to give you another example of what you potentially might see. So AKS 60 also refers to rewriting from radical to exponential. Okay, so I'm going to show you that in just a second. So if you're trying to write this down on a piece of paper, I would either like take a picture with your phone, screenshot it, because I'm about to hit clear. Okay. So another example of this, AKS 60, is going to be something like if I had the square root of 81 x raised to the 5th power y to the 3rd power, and they said rewrite in exponent form. This pen really doesn't like me today. I'm so sorry. Okay, so what I mean by that is, remember, if you got the square root, that means that there's this little 2 chilling in this little cubby hole. Okay, so I'm going to rewrite all of these numbers or all of these variables, etc. And instead of writing the square root, I'm actually going to raise this to the 1/2 power. Okay, so remember, taking the square root, same thing as raising it to the 1/2 power. So now I'm going to use my exponent rules. You remember on the last one where we said a power raised to a power? What are we going to do? We're going to multiply. Okay, so 81 raised to the 1/2 power. I'm just going to write it out. X to the 5th raised to the 1/2 power. That's going to be x to the 5 halves. And then y to the 3rd raised to the 1/2 power is going to give me y to the 3 halves. Now, you can take the square root of 81, right? So 81 raised to the 1/2 power is just going to give me 9. And we can't simplify these two, so we're just going to leave those guys alone and just write them right here. And that would be my final answer. Okay. So again, they would probably ask this like simplify and rewrite it in exponential form. Okay. One second. has to move. There. Yes, I can. And yep, I'm going to go over constraints in just a second and number 50. Okay, so I'm going to go ahead and jump to number 50, and then I'm going to talk about constraints. So jump into 50. Yeah. Okay, inverse functions. You're definitely going to see like 2 or 3 of these ones. I would bet that there's going to be like 2 over logs or exponentials, and it's going to be like find the inverse function, or compositions, which again, I'll talk about that in just a second. So on 50, if I'm going to do the inverse function, the first thing I'm going to do is I'm going to switch my x and y. So x equals 3 log of 1/5 of y plus 2. Okay, so we want to get our log by itself. So we're going to divide by 3 on both sides first. And so that's going to give me x divided by 3 equals log of base 1/5 of y plus 2. Now, in order to get rid of the log, we're going to use what I call the circle of life. Okay, your teacher might call it rewriting using an exponent. I can't think of anything else that they used. I think that's it. But what you do is you always start at your base, you go to your outside, and you finish over here. Okay, so you're going to say 1/5 raised to the x divided by 3 equals y plus 2. Okay, so how I got that for my visual people is I started here, I went to my outside, I finished over here. Notice how that's the order that I wrote it in. Start at my base, go to the outside, finish over there. Okay. Now we want that y by itself. So we're going to subtract 2 on both sides. And so our final answer is going to be written out as y equals 1/5 raised to the x divided by 3 minus 2. This one's a little messy, and I apologize. Yeah, I didn't write this one. I mean, I picked it, but okay. No problem. Okay, I want to talk about one thing with inverse functions, and that is you're probably going to have one of the questions say, verify that these are inverse functions of each other. Okay, and so let me go through what that means. So I'm going to hit clear in just a second. So if you need to take a picture of it, because I know I'm moving quickly, I will post this video later on. So, all right, 3, 2, 1. Okay, so like let's say that you had f of x and it equaled x plus 2. And let's say you had g of x and that equals x minus 2. And your question says verify that they are inverses. Okay, what you're going to do in that instance is you're going to do the composition. Okay, so that's what this little mess right here is. You're first going to write out what f is, and so that's x plus 2. And then you're going to take g and you're going to write it in for that little x. So I'm going to write it in here. So that's going to be x minus 2. So notice how g, the whole thing of g, is now plugged in for that x. And then now we're going to simplify. So what's negative 2 plus 2? Has 0. And so what do we equal? X. So if you do the composition, that's what this is called, of these two functions, and you get x, then they're inverses of each other. Now you do have to check it both ways, but like 99% of the time, it works if you do it just one way. Okay, So G of f of x means that I'm going to write out what G is. So that's x minus 2. Okay. And then I'm going to plug in where this x is. I'm going to plug in what f is. Oops. I'm going to plug in what f is. And then again, I'm going to simplify. And so that's going to equal x. Okay. So you need to know that if they're inverses of each other, if you did the composition, you're going to get x. Okay. Another way to see this, like if you're like, nah, I can't plug them in. If you go into Desmos and you do x plus 2 and x minus 2, and you graph y equals x. Let me show you this one. You see how if you tilt your head to the side, they're even on both sides. It kind of looks like symmetrical. I think of like butterfly when I do compositions. Like if it's symmetrical on both sides, boom, those are inverses of each other. Okay. All right. So that's my little rant on that. Going back. But I think you're going to have a couple of questions like this on there. There's going to be like 2 or 3. Okay. One of them is going to be about composition. The other one's going to be about log. And then one is going to be like a normal function, find the inverse. And I would think that they're going to use like a quadratic. Like they'd be like y equals x squared and y equals square root of x. Verify that these are compositions of or inverses of each other. Okay. Again, this is me just taking a shot at the dart and just kind of assuming that's how the county's going to write their test. Definitely need to know how to graph. And Tiff, you asked about constraints. Okay. So I didn't put any word problems on your final exam review, but what I did do is I gave you inequalities. Okay. And I told you to graph them. So looking at like 55, for instance, okay, if you take this and you plug it into Desmos, okay, so let me write it down really quick before I switch screens. Okay. If you take this and you plug it into Desmos, negative x. So that's 2 and 1, that's 3. Okay. And let's say that we're talking about like a real world scenario. So remember, we don't live in negative number land with real world stuff. Okay. That means that we can't have any solutions outside of here and outside of here, right? So it only can fall really where this dark blue shaded region is, okay? So these are constraints, which means that, like, let's say we were talking about, iPhones, okay? And this said essentially that you couldn't sell more than 3, okay? You have to sell less than 3, okay? And then over here, this is, it had to be greater than this equation. I don't know why you would write it like this, but just for this purpose, okay? The solutions can only be inside of this area, okay? And that's it. So with constraints, normally it's going to say, what would be a potential solution? Well, if they give you options for your solutions, just plug them into both of these constraints and they have to work for both. And then you're good to go. So like, for instance, I'm going to just like pick a point. Like, let's do 5, 1. That's a good one. Okay. So 5, 1. That means I'm going to plug it in here and it's got to work for both of these. So for this first inequality, I'm going to get 1 is greater than or equal to negative 5 plus 2. Well, what's negative 5 plus 2? That's negative 3. Is that a true statement? Yes. Okay, let's check the other one. Well, our y value is 1. 1 is less than 3. Is that a true statement? Yes. Okay, so 5 comma 1 would be a solution, a potential solution. Okay. Now, if they ask something like, how do you maximize your profit? You want to check for the corners. Okay, so what I mean by that is, let's say that there was a cap off on this one at like x equals 2. Okay, so this would take this region down to here. So you would pick these 3 corners. So we always do the corner method. And again, I don't know if your teacher actually said corners, but you would take the corners of those boundaries and plug it in to whatever the profit equation that they give you is, and then see which one gives you the best option. Okay, sometimes they say maximize profit and sometimes they say minimize. So just make sure that you're paying attention to the wording. Okay, I think that covers most of it. Okay, cool, good. That covers constraints. If you have any specific questions that you want me to go over, again, you're going to just drop them in the chat box, and then we'll kind of go from there. But coming back to this document, okay, we just hit constraints. We did solving radical functions up at the beginning of our review guide. And then 23 and 24 is dealing with normal curve and z-scores. Again, there's 5 questions on that. I would expect you to have 1 to 2 questions on empirical rule, 1 to 2 questions on the normal curve, and 1 to 2 questions on the z-score. Okay. Somebody mentioned something. 54, got you. Okay, let me go back to that. Yeah. So this is dealing with those word problems. I'm not sure if you actually have one like this one, but again, just trying to give you different scenarios. So 8 upright dominoes of increasing height are lined up to be knocked down. The dominoes are numbered 0 to 7. The smallest domino is 0, which is 4 centimeters tall, and will be toppled by a person to start the chain reaction. Each subsequent domino is 15% taller than the one before. What's the height of domino number 7? Okay, so this is going to be an exponential function. Reason why I know that is because they give us an initial amount and they give us a percentage that it's increasing by each time. Okay, so A is our initial, which is going to be 4 because that's our first domino that we start with. Now they tell us 15%, okay, that it's growing each domino by. So we're going to say 1 plus 0.15. The reason why we're saying 1 plus is because you're taking the previous domino and adding 15% to it. And then that's giving you your next domino, okay? And we want to know what number 7's height is. So we're going to raise that to the 7th power. So that's our x. So when you plug this into your calculator, this is going to give you, I think it was like 10.64. 10.64 centimeters. Somebody correct me if I'm wrong on that one. Okay. Doing that just off the dome, you know. Okay. Yeah, that's a good one. I don't think you're going to have one like that, but you could. It would be a fair question. Any other ones you want me to go over? Sorry, my dog's in the background. 20. Okay. And 17. Got you. Okay, so let's go to 20 and then 17. Yay! I love these ones. I know, I'm crazy. It's fine. Okay, so 20. This is using our exponent rule. So this is at AKS 60. Okay. So we're going to take each of these things and we're going to raise it to this 0.5. I would change this to 1/2 just because it makes it a little easier to deal with, in my opinion. So 1/2. Okay, so 81 raised to the 1/2 power and b to the 4th. And we're going to multiply that by 1/2. So what's 4 times 1/2? Well, that's going to give me 2. And 81 raised to the 1/2 power, that's the same thing as taking the square root of 81, which is just going to give us 9. Boom. Okay. On 17, you're going to do something similar. So remember, when we have that negative exponent, we're going to go ahead and flip that guy. Okay, and this 1.5, we're going to change that to 3/2 because that's what it is in fraction form. If you were unsure about that, you could type 1.5 into your TI-84 and you hit math enter, it'll give you it in fraction form. Okay, so if you didn't know 3/2 was 1.5, that's one way you could do it. So I'm going to rewrite this as 1 divided by 49 r raised to the 2nd power raised to the 3/2. And we're going to take each of these things and raise it to the 3/2 power. So 49 raised to the 3/2, r to the 2nd power multiplied by 3/2. And when we multiply 2 times 3/2, that's going to just give us 3. So I'm going to rewrite this. 1 divided by 49 raised to the 3/2, r to the 3rd. And when we take 49 and raise it to the 3/2 power, I don't remember this one off the top of my head. I think it's 343, but I don't remember. Dang, I'm good. Okay, so going back over here. Sometimes I amaze myself. So this final answer will be 1/343 r raised to the 3rd power. Okay, so again, I use the negative exponent rules, and then I use that power to a power rule. Okay. Anything else y'all want me to go over? Trying to see if there's like one that y'all notoriously do bad on. Unit 7 review. Yeah. Oh, let me teach you how to do that one. Okay, yeah. Okay, let me pull up that document. So I got a question on Unit 7 review, the first question. Yeah. That one's a little tricky. It's under here. Sorry, I didn't have it pulled up. My bad. Okay, so on this one, is the mean greater than, less than, or equal to set B? Is the standard deviation greater than, less than, equal to set B? Okay, use your Desmos. Okay, so I'm gonna write out all of these. So each dot represents one number. So this is gonna be 10, 15, 16, 3 18s, 2 19s, and 2 20s. Okay, so I'm going to go into Desmos because I'm not doing this by hand. Okay, and I'm going to hit this little plus sign and I'm going to hit table. Okay, I'm going to type each one of those numbers into this list. So we got 10, we got 15, we got 16, we got 3 18s, we got 2 19s, and then 2 20s. Are that right? 1, 2. Yep, that's right. Okay, so I've typed all my data in there. In order to find the mean for this one, if you wanted to do it by hand, that's fine. It's great. You're going to add all of them up and then divide by how many numbers there are. I ain't got time for that. So mean, and I'm going to put x sub 1 or whatever the title is right here. Right here. And boom, 17.3. So the mean is 17.3. And then I'm going to do the same thing, but I'm going to do it for standard deviation. And for some reason, Desmos makes you do standard deviation P. And you're going to write that x sub 1. And there it is, 2.87. So I'm going to write those two down. Okay, so for me, nope, just kidding. Mean is going to be 17.3. And standard deviation is 2.87. And you're going to repeat the same process for the other data set. So you have to do it again. Okay, so coming back in here, I'm going to write all those numbers down. 10, 13, 15. Wow, 15 3 times, 16, 17, 18, 19, and 20. And again, I'm going to go back in here to Desmos. One thing that's great is once you've done it once, you can just write over the numbers. So okay. And automatically, once you scroll down, boom. If those things are still there, there they are. So that means that my second data set is 15.8 and my standard deviation is 2.79. Okay. And so I'm going to go back to my question where it says which one's greater than or equal to. Okay. So we would say that set A has a greater standard deviation and mean than set B. And that's it. That's all we're going to say. Okay. While we're on this page, if you get on here to number 3, just going to do this one kind of quickly because I think it's important and I think you're definitely going to be asked this one. Remember, you're going to be given the formula for z-score, but just in case you don't know it, we're going to have x minus mu divided by standard deviation. So that means that our student score was 92. We're going to subtract 80 and we're going to divide by 7. Okay, so that's going to give us some number that I don't know off the top of my head. 2 minus 8. Nope. 1.71. Okay, and that's it. So if it asks specifically for z-score, you're going to use this formula and be done. Now, if it asks for the probability, then what you're going to do is you're going to go to your z-score table, okay? And that will be given to you. It'll be at the bottom of your formula sheet. Okay, so just keep that in mind. When you're looking, make sure that you're on the positive one. But for right now, if I pull up a z-score table, and it would have to ask something like, how many students got a score 92 or below? So 1.71, so that's going to be 0.9564. 0.9564. So that means that 95% got a 92 or below on this exam. Okay. I don't think you're going to be asked any questions on like number 5 or number 6. But I just asked those questions just in case on this final exam review. I don't think you're going to be asked that question though, because the AKS says 23 and 24, which is just over that normal curve and empirical rule. It'll ask something like, what range is 95% of the data? And like, let's say you had 70 as a mean and 5 as the standard deviation. Then you would set up that normal curve. And remember, you're given this percentages, so if you forget them, that's okay. But within 2 standard deviations, that's going to be 95% of your data. So the range is going to be from 60 to 80. The range would be, in this case, from 60 to 80. Okay. Any other questions that you got? Okay, I think I hit just about everything. Just a little bit of everything. Let's see. $26 is the next one. 20. Okay, so rewriting this guy in exponential form. Okay, so remember, if we have the cubic root of something, that's the same thing as taking it and raising it to the 1/3 power. But in this case, we also raise that to the 2nd power. So we're going to multiply these 2 powers together. And so that's going to give me 4r raised to the 2/3. Now, we could leave it like this, or we could go ahead and distribute that exponential or that exponent. So that's going to give me 4 raised to the 2/3 r to the 2/3. And you always want to check and see if you can simplify this at all. So if I took 4 to the 2/3 and I plugged it in here. I'm so sorry. It gives me a decimal, so I can't simplify that, right? Okay, so then this would be it. Okay. Somebody asked for 51. Yes. A new social media site is increasing its user base by approximately 6% per month. If the site currently has 21,490 users, what will be the approximate user base in 10 months from now? Okay, so remember, this is going to be that exponential. So it's going to look like this. And it's growing because it's saying it's increasing, right? So that means my initial was 21,490. My rate is 1 plus that 0.06 because we're taking the initial users and adding 6% each month. And we want to know what it's going to be in 10 months. Okay, so we're going to put 10 as our exponent. And because I'm not doing this math in my head, we're going to type it into our calculator. We're going to raise it to the 10th power. So that's going to be 38,485.32, which you can't really have half of user. So we're going to say 38,485. And that's it. Okay. So are there any questions on this one? Are there any other questions on any other problems that you want me to go over? Okay. We're 17. Okay. All right, so I think I did this one earlier. Okay, let me do this again. Okay. So on this one, just as a reminder, if you already seen this one, that's fine. It's okay to see it twice. So this negative exponent means I'm going to flip this one. And I'm going to change that 1.5 to a 3/2. Okay, so I'm going to take this exponent and I'm going to distribute it to everything that's in the denominator. So that's going to give me 1 over 49 raised to the 3/2 r to the second raised to the 3/2. So if I have r to the second, give me 1 second. My dog is driving me nuts. Okay, so when we multiply that r squared and that 3/2, then that's going to give me r to the 3rd power. And if we take 49 and raise it to the 3/2, if we just plug that into our calculator, we're going to get 343. So our final answer is going to look like this. No, if a point falls on a dotted line, no, it's not going to be considered a solution. It's got to be like in the shaded region or on a solid line. Yep. Yeah. Just kind of referring y'all back to this document because I always get asked these questions and I'm trying to like avoid them. How many questions are on your exam? There are 24. And there are 8 questions, and here's the AKS that it's broken down by. So if you looked at your final exam review, you can see like the different AKS. I like hand wrote it. I apologize for my handwriting. On your final exam review guide, we hit most of them. I think we hit all the different types that you're going to see. The only thing that I think I would be super worried about for y'all, again, I think would be like AKS 34 or 38. And I think it's going to be in context. And I don't really know how to prepare you for a word problem that I don't know they're going to give you it. Okay. So with that being said, you really just want to think about real world context. Like, don't go negative infinity to positive infinity just because that's the only thing you know. Think about it in real world. You can't have negative numbers in the real world. Okay. Now, if it's a function and there's no context, there's no words or anything, there's no situation, then negative infinity to positive infinity would work. Okay. No problem. Okay. All right. Anything else? Okay, so I'm gonna hit stop recording. If you want to stick around for a couple of minutes and ask like last minute questions, that's fine. If for some reason your teacher didn't give you the review videos, I'm gonna post those really quick in the chat box. Okay, so Let me drop those really quick. So everybody, that one. Hopefully you can see that. I don't know if it's just linked to my e-class page, but the other one that I think I'm a little worried about with y'all is just that unit 7 stuff, that AKS 23, 24. Again, I don't think it's supposed to be designed to be super difficult, but just in case there are the links for it, please study. Please don't expect to walk into your class and like somebody give you the answer and like you be good to go. No, you've got to study for this one. Okay. All right. So with that being said, I think I've given y'all a lot to think about. Thank y'all for coming today. If you want to stick around and ask me any more questions, that's fine. But good luck this week and good luck next week if that's when you're taking it. Take your time on it. Do well on this. Okay. So I'm going to hit stop recording.